when we were solving these, and I'm going to just go over here for just a second, like I referenced 2 questions on our homework. We got to a point where we had like this plus or minus, possibly. And we had that in our notes yesterday, which was fine. And I said we'd come back to it. So what I just didn't want to try to do too much at once yesterday. But one big point here is that when we go backwards from a derivative to an original, we can never make any assumptions. So I don't want to call this necessarily a definition, but lack of a better term here, we're going to say this is kind of a rule, okay? The solution to a differential equation must be a continuous and differentiable, I'm trying to use a lot of different colors here, function. The solution to a differential equation is a continuous, differentiable function with the largest domain that contains the initial condition. I'm going to explain what that means. And I'm going to use, actually, I'm going to use something that we had in our homework yesterday. Or not our homework, our notes. Yesterday in our notes, we got to a point that said something like y equals plus or minus the square root of negative x squared plus 5. Which, by the way, I don't remember if I wrote it this way yesterday. I probably would have written as 5 minus x squared. Doesn't matter. This is a point that we got to in our notes yesterday. And I said we'd come back to this, and this is when we're coming back to it. So when we do this, this is technically a semicircle with a radius of radical 5. So I have the positive square root, that's the top half, and then the negative square root, that's not a very good circle, just use your imagination, is the negative square root is the bottom half. So this is y equals the negative square root, and this is y equals the positive square root. So first of all, if I included the plus or minus, it doesn't meet this condition. It's not a function, right? This does not pass the vertical line test, and that's the problem. In our notes yesterday, I think, oh my gosh, I already forgot what our initial condition was. I think it was the 0.2, -1. Can someone remind me when we did this one in our notes yesterday? I don't have it. Does anyone find it? The initial condition?
Yeah, -1.
Thank you so much. Okay, so I could have just gotten up and walked over and dug through my binder. So our initial condition, thank you, was the 0.2, -1.
Actually, I messed up. It's -1, 2.
Oh, that's okay. That's okay. -1, 2. Okay, thank you. So our initial condition is left 1, up 2. Our initial condition is on the red part. It's on the top half, which means we would have only said y equals the positive square root of 5 minus x squared, because that's the function, the red part, that contains the initial condition. Okay? So we're going to practice this, and we'll talk about how do we do this without knowing what the graph looks like, because we won't always know what the graph looks like. I absolutely agree with you. Okay? All right, which means we will not have pluses or minuses in our answer anymore. We also may have to make some adjustments for our domain, okay? So I'm going to reference 2 from the homework because we already have done the work. Your answer may look a little bit different depending on when you solve for C and all that good stuff. But let's take a look at this one. This was number 1 from worksheet 1. We were given the derivative equals x over y. The initial condition is the 0.12. One of the conditions says it has to be differentiable. Differentiable means the derivative must exist. Well, look at this over here. I think we could all agree when we say the derivative will not exist when y, that's a y, started right next, when y is equal to 0, right? You can't divide by 0. So if y is equal to 0, I have a problem there. So I'm just going to hey, look, here's a quick graph. I'm not drawing the function. I'm just going to draw my axes. The problem is that y equals 0. The derivative does not exist here, which means my answer cannot include y equals 0. And if it can't include y equals 0, that either means I'm on the top or on the bottom. So if the problem is at y equals 0, we need to figure out where we're going to be. How do we figure that out? We're going to use the initial condition to make that determination. The initial condition is the 0.12, which is above y equals 0. So when we had a plus or minus there, just like we did on the last slide, we're only going to use the positive square root because the y coordinate is a positive number, right? It says y equals plus or y equals minus. Well, y was positive. And I know some of you are going, oh my gosh, I'm never going to remember this, or it's a lot of extra. It's not a lot of extra work, and it's actually going to make our answers a lot easier to work with, okay? Let's take a look at the next one. So this was question number 2 from your homework, and depending on what you did, and I've made a bit of a mess here, but depending on what you did and kind of how you simplified some things, or when you found C, you might have gotten one of these 2 answers, okay? Well, let's go back. It has to be continuous. We'll deal with that in a minute. It has to be differentiable. Well, there is a problem when x equals 0. The derivative does not exist at x equals 0. So I'm just going to draw myself a quick little graph. Here's x equals 0, which does not give me a top and a bottom anymore. It gives me a right and a left. If my derivative does not exist at x equals 0, that means I can't include x equals 0 in my answer. And if my answer needs to be continuous, that means I either pick the left or the right. Pick the left or the right side of y equals 0. How do I determine that? We use the initial condition. The 0.22 happens to be to the right. Now, what's tricky about this one is that the whole plus or minus, well, that's like a top or bottom. So we'll deal with that as well. So I'm definitely for my answer going to say, stop me. Look at what I just did. I wrote y and I meant x. You got to, keep me in check here. Pick the left or right of x equals 0. I'm so sorry. And so we're going to take this answer right here. First of all, we can't have the plus or minus because it's not a function. So if you still had that in your answer, we would need to get rid of the minus because we can't have a positive square root. I'm sorry. Geez, a positive absolute value and a negative absolute value. We can only have the positive one because we're on top, so definitely no negative. And we have to add for x greater than 0. We have to physically write that as part of our answer, right? We can get rid of the plus or minus by just getting rid of the minus, but we have to specifically say that we can't use this left side, okay? How did I know it was an absolute value? Well, look at it. It says y equals the absolute value of x. So I know that this was my answer, but it's not differentiable at x equals 0, so I can't use anything to the left of 0. So I can only use this piece right here. So I have y equals the absolute value of x when x is greater than 0. So that's my only answer. It's the only thing I can confidently say without making any assumptions. Whew, I made a mess and I'm so sorry. Let's do another one. Let's start from scratch, okay? Kind of talk about how we're going to walk through these. So I gave us a lot of space. You may not need all of this space, but I don't want us to have to cram things in like clearly I just did on the last slide. So it says we have 2 of these to do today. Solve each differential equation and state the domain. And I should have said state any restrictions on the domain because, if we don't have any problems, then we won't need to say anything. But So it says find the equation of the curve that passes through this point. So here's my initial condition. And has a slope, remember slope means derivative, of 1 over xy. All right, so let's write that down. The derivative equals 1 over xy, right? The slope, the derivative. And again, we have that initial condition I boxed in red. Now, before I do anything, I'm going to ask the question, where does the derivative not exist? So I'm looking at the denominator. In fact, I'm going to say the derivative does not exist when x equals 0 or when y equals 0. We have two problems with the derivative. You know what I'm going to do? I'm going to sketch that graph. I have a problem when x equals 0, which means I have to pick the left or the right. I also have a problem when y equals 0, so I have to pick the top or bottom. My initial condition has a positive x and a negative y, which means my solution has to go through that point, which means I'm going to live in the fourth quadrant. My answer can only live in the fourth quadrant. So when they say state the domain, we should also even just say any restrictions on anything. So part of my answer, and we can adjust this later, so part of my answer is x has to be greater than 0. I need to be on the right side of this problem, but y has to be less than 0. That's part of my answer. I'm going to box it in. These are our restrictions. So again, I determined where the derivative did not exist. I looked to see where my initial condition is, which means the only part of my answer, or my answer can only live right in here. So whatever my answer is, I'm going to make those statements along with it. Okay, now we're ready to do what we were doing yesterday. So now that I have all this space, I'm going to go ahead and use it. dy dx equals 1 over x times y. And now we're going to do everything we did yesterday. So I'm going to multiply the y to the left and the dx over to the right, whether you write it all down or whatever is comfortable. So I have y times dy equals 1 over x times dx. And now I have two separate, easier integrals to worry about. So I'm going to integrate both sides. I like this piece. The antiderivative of y, we add 1 to the exponent, divide by the new exponent. So I have 1/2 y squared. And then on the other side, well, we know that one. It's the natural log of the absolute value of x plus c. Okay, so we have choices. We have a lot of choices. It is completely up to us. When we were talking about number 3 on homework, I think it was 3 Kelly asked about, I said we have two things we have to do. We have to solve for y, and we have to find c. And it does not matter which one you do first. One will be easier sometimes to do first. So it's completely up to you. I'm going to be honest. I'm going to just multiply everything by 2. And I'm going to talk about why I'm choosing to do this. But I like to get rid of the fraction, first of all. So I've got y squared here equals 2 natural log of the absolute value of x plus, and I realized after we hung up yesterday that I forgot to make a big deal about this in our notes yesterday when I multiplied everything by 2, so I apologize. But when you multiply a constant by 2, it is still a constant. I wrote it yesterday. I didn't say it, and so I apologize, and I wish some of you would have asked why or what happened. But here's what happened. This constant is a different constant, so we have to make sure we're aware of that, but it's still just a constant, okay? So I realized I never really addressed that. I apologize, because that's kind of funny. I would not necessarily try to get caught up in changing the letter. Like I've had students before say, well, if that's C and then I multiply it by 2, maybe I'll call that D and then I'll call the next one F and G. I skipped E for a reason. I don't know if I would recommend that or not. Certainly you can try it if you want. Okay, if I'm trying to solve for y, the next thing I would do is take the square root of both sides, which means now c is inside the square roots. You know what, maybe we solve for c now. So I'm going to go plug in my initial condition. My y was -1, and my x is equal to e. I left the absolute values off because, well, it's already positive, right? The natural log of e is 1, right? So 2 times 1. And so I get c is equal to -1. Here's where you have to be careful. We've got c's in a couple of different places. Remember, this c and this c are not the same. I used this purple line to find c, so I need to go back and plug that c in here. I can't go back here because, well, then it would be wrong. So I'm going to go straight back there and say y squared equals 2 natural log of the absolute value of x minus 1. Remember, this c is twice as big as this c. So if I use this line to find c, I need to go back to this line. Okay. Awesome. The last thing I have to do is take the square root of both sides. So temporarily, I'm going to say y equals plus or minus the square root of 2 natural log of the absolute value of x minus 1. All of that's in that square root. Now remember, way back over here, I already said this is part of my answer. I need to make sure that my x is greater than 0 and that my y is less than 0. Okay, well, we can take care of this with the plus or minus, right? It says y equals a positive number, y equals a negative number. Well, if we're saying y is negative, then we're going to just take care of that there. So y equals the negative square root. And then we can say for x greater than 0. That's one way we could write our answer. Whoops, it's not simplified. That's okay. But I took care of the y being less than 0 by just using the negative instead of the plus or minus. Now, if x is going to be greater than 0, then I don't need the absolute values anymore. So we could get rid of those. Now, I would still need to say for x greater than 0, right? But I definitely just don't need the absolute values anymore. So that's one way to simplify it. Now, the nature of this problem is you can't plug a negative number in for x anyways. So the natural, this is just kind of, look, I already boxed in our answer. Some of us are like, fine with that. But if x is greater than 0, I mean, it has to be anyways. The natural log takes care of this. But to be on the safe side, I would probably have left that in my answer. So I would say most of you will be very content leaving your answer just like that. So we had 2 restrictions. One, we got to take care of with the plus or minus, and then the other one we just wrote down. We said x has to be positive. Okay. But this is the more simplified version. Okay. Woo! How does that look for us? Let me take a pause for some questions.
Couldn't you have just put the, like, kept your original thing and put the for y is less than 0? Like, it would be redundant, but, like, would that also be accepted?
Absolutely. You're saying like this first box here or this red one?
The plus or minus one, yeah.
You could. I'm going to be honest with you. These questions are on the AP test all the time, and they're going to be in multiple choice. And so you're going to need to be comfortable with choosing a plus or minus. So I would think, and Matt, it's a great question. You're correct that you could do that. But if we're thinking about multiple choice answers, I want you to kind of practice eliminating that plus or minus. But you could. You could also just go in here and say for x greater than 0 and y less than 0. That is fine, but you're right. A little redundant then. Perfect. Okay, great question. All right, let's flip it over to the back and take a look at this next one. Again, I just gave us lots of room. I'm not saying it's necessarily long or that we need that much. Just feel free to take up your space. So a couple of things here that are different is, well, first of all, the derivative is not isolated, right? It does not say dy dt equals. In fact, it says all of this junk is equal to 0. We'll take care of that. We saw something like that yesterday. The other thing is that it's not dy dx, it's dy dt, meaning we have t's instead of x's. But that's okay. We're just going to treat our t's as our x's. Okay. So the one we did yesterday, and same thing, we need to start with the derivative. If we want to integrate this, I would like to isolate dy dt. So let's add the y to the other side. And then let's divide by that 1 minus t. So we've got dy dt equals y over 1 minus t. This is a huge step, right? Because how do we separate with multiplication and division if we still have addition and subtraction? And so this is a really big step for us to see the derivative equals, and then that quotient or product of x's and, well, y's, t's and y's. Okay, before I do anything else, the derivative does not exist when t is equal to 1. Remember, t is like my x, which means we have a problem when t equals 1, which means we need to pick a side. How do we pick a side? We look at that initial condition. The point is x equals 2, y equals 3. Well, if this is 1, the point 2, 3 is on the right side. So my answer, and we may adjust our answer at the end, is my answer has to be on the right side of 1. So we're going to say t has to be greater than 1. That's part of my answer. Whether I let the answer kind of take that on or we leave that, that's a big deal. So we talk about the domain.
I have a question.
Yes, go ahead, Adam.
Is it ever going to be like greater than and equal to? Or
No. No. And so I'm going to go, great question. Because when we go back to the front, it has to be differentiable. And if the derivative does not exist there, then we cannot include that in our answer. Right? If there's a problem at 1, we cannot include 1. Does that help?
Yeah, I got you.
Good. Great question, though. So we have to pick a side, and we cannot include the 1. Great question. All right. With that being said, so I kind of just did my whole domain thing. I'm going to go back here. I'm going to just rewrite it because look at all the space I have. We may as well use it. I'm going to go ahead and rewrite my derivative, and now I'm going to solve it just like we did yesterday. Remember, the t's are like my x's. So the t's are going to stay on the right? We'll multiply that dt to the other side, and I'm going to divide the y over. So I have 1 over y dy equals 1 over 1 minus t dt. But by the way, everything at this point now are things that we've seen. Starting in January, we've been able to take these antiderivatives. I know one of the ones I did yesterday had u substitution in it. That was, I get it. That was not very nice of me. But these are pretty friendly, aren't they? So we're going to integrate both sides. So the antiderivative on the left is the natural log of the absolute value of y. I'm going to go to the other side. This is where we still have a natural log, right? It's going to, I'm going to leave a space here. The natural log of the absolute value of 1 minus t. But pause, because the derivative of the inside is -1, so we need to divide by -1, which is the same as multiplying by -1. That's a big deal. We can't forget that. Right, so the derivative of this inside was -1, so we divide by -1. Woo! Okay, so at this point, we have 2 things we absolutely need to do. We need to solve for C, and we need to solve for y. And you know, there's a couple things we can do. And as we talked about number 3 on homework, we saw how different those answers looked depending on when you did what. I'm just going to ask, who has a preference? Do you want to find C or do you want to solve for Y? Does anyone care either way?
You should find C.
Okay, let's find C. That's fine. So let's go ahead and plug in our initial condition. X is 2, Y is 3. So I have the natural log of 3 equals negative natural log of, let's see, 1 minus 2 plus C. The natural log of 1 is 0. And so C equals the natural log of 3. So we're going, okay, yeah, good. That was nice. That was pretty straightforward. So I have the natural log of the absolute value of Y equals negative natural log of the absolute value of 1 minus T plus the natural log of 3. Ew, I know. Gosh, look at all that.
This might not be how that works whatsoever, but can you just take all the natural logs out?
Ah, great question, Matt. The answer is no, not right now. But we can certainly talk about that. Let me grab, I know we have lots of space. I'm just going to grab a Post-it so I can move it later. Matt is asking, I'm going to use just random letters. What if I have the natural log of A equals the natural log of B plus the natural log of C? Agreed? Matt is just saying, can't we just say A equals B plus C? And the answer is no, not right now. However, if we were to combine these natural logs, remember, and I know this is not the same as what we have, but if you have 2 logs with addition, you can write those as 1 log with multiplication. And then, so I'm going to put a big X there, then you can get rid of the logs. So I like, Matt, that you asked, because you're right. We have a lot of rules with logarithms and properties and ways to get rid of them. You can only remove the logs if you have a single log on both sides. And we can do that. With what we have, we can do that. So maybe I should ask, do we want to clean that up so that we can get rid of the logs? Does anyone feel strongly about doing that, or do you want to leave it alone?
Yeah, kind of.
Yeah, you should get rid of those.
You should. Okay, then let's do that. So this is why some of you will be frustrated, is because you're going, I wouldn't have thought to do that, and my answer is going to look different. That's okay. I cannot stress to you enough that when we do these, many of you will have different looking answers and different steps along the way. That's what makes it frustrating. Now, what I notice is that this is a negative, right? So maybe I switch the order here and I have the natural log, excuse me, of the absolute value Y equals. I'm just going to switch the order so that I see 2 logs with subtraction. Because then I can write that as 1 log with division. Ooh, you know what? This is actually really nice. And this looks a lot different than how I imagined us doing this one. But you're going to like this. Yeah. Now that we have the log of something equals the log of something. Oh my gosh, that's it. That's okay. We'll finish this. We can say the absolute value of Y equals 3 over the absolute value of 1 minus T. Which means we have Y equals plus or minus, whoops, there's my absolute values, plus or minus our fraction. Now, we have a plus or minus that we didn't really see happening, right? We have to deal with that. Ooh, go back to our picture. Or go back to our initial condition. Would you agree Y is a positive number? So I'm going to say Y equals the, I don't need to write that. I'm going to do it anyways. I keep forgetting my absolute values. So we have to pick one because we can't have both. So we picked the positive because our Y value is positive. Everything else stays the same, but remember from the very beginning we said T Has to be greater than 1. Woo! And I know the bell rang, so if you have to leave, you have to leave, but I'll hang on here just for a moment as you get this written down and as you have questions and all that good stuff.